Hi, in this session we will discuss about thread class in the multi-threaded programming. Thread class is having two primary thread control methods, that is here run method and start method. For example, the structure is given here. This is the thread class which is having a start method and run method. The purpose of run method is to write a few lines of code to perform some task. The task will be taken by this method by performing some action on that particular calling thread object. Here the start method is used to start the execution of the thread. For example, here for this run method we will define one thread that is called T1. This should be started by using some method. That method is here used to start the uh, thread is called here start method. JVM is calling the run method on a thread. When you are calling this start method, automatically the Java virtual machine in the background call this run method to execute. The thread dies whenever the run terminates the execution. That means if the run method is completed its execution by executing these instructions available in this run method, then automatically it will be terminated. And user never calls the run method explicitly. That means we need not to invoke this run method by using any object. For example, here T1 is the object. We need not to invoke that method by using this object, so it is not at all needed. This is explicit invoking of that method. It is not at all needed. The Java virtual machine itself, whenever we are executing the start method, in the background it will call this run method by automatically or implicitly. The start method is moving the thread from new state to runnable state. That means there is a different states available in the thread. We will see in the next slide. So whenever we are calling the thread by using start method, automatically it will alert the CPU, right? The thread will alert the CPU for that particular calling thread. That means T1 or whatever method we are calling the start method. For this T1, CPU will be alerted for starting the execution. When thread is getting the CPU to execute, then automatically it will execute the run method. Once the CPU is alerted for this thread 1 by thread scheduler, automatically run method will be executed implicitly by the Java virtual machine. Here these things will be taken care of thread scheduler. That is one of the software tool in the Java virtual machine. So this thread scheduler will take care of the running of this start method and run method and complete the termination of thread. Everything will be taken care of by using thread scheduler. And also there will be some queue. It is maintaining some data structure called thread queue. So this queue will be used to store the threads which are running in the CPU at the current time, and some of the threads may be waiting for its turn for getting the CPU. So those threads also will be keeping in the thread queue for getting the CPU for its execution. Here the thread lifecycle is given in this picture. Once the thread is defined, the new thread will be created here by using some object variable with the user defined thread class. Once the new thread is created by using the object variable, then we will initiate that thread by using start method. Once start method is executed, then that thread T1 will get into the active state. Okay, so active state is having two different process. One is runnable and another one is running. That means if start method is executed, T1 is coming in the runnable portion. This runnable portion is ready to alert the CPU if CPU is idle, right? You assume that CPU is idle. If CPU is idle, then immediately T1 will be allotted with that CPU for executing by thread scheduler. Okay, so thread scheduler is allocating the CPU for this T1 thread. Then thread 1 is getting inside the CPU. So now which is executing by the CPU, that state is called running state. So now thread 1 is in the running state for its execution. Suppose in between the thread is suspended, right, for some reasons, then we can use the suspend method. Once it is suspended, it will get into the non-runnable state, that means blocked state. Okay, otherwise sometimes the thread 1 may be keep in sleep mode for a number of milliseconds, 10 milliseconds or 20 milliseconds, due to some reasons, then it will call the sleep method. Then that T1 will keep in the blocked mode, that means non-runnable state. Otherwise sometimes it may wait for some in IO operations, input output operations. At that time also it will be kept in the blocked mode. And another one option is here, due to some getting lock, okay, for getting the locks, okay, mutual exclusion locks, like that, it will be kept in the blocked mode. So under this any situation, right, the thread, running thread, can be kept in the blocked mode. What is the blocked mode? That means you see here the thread 1 is running by the CPU, that means executing by the CPU. That execution will be stopped, right, and that thread will be kept in the non-runnable mode, that is CPU is not allocated for that T1, that is T1 is taken away from the CPU, right? So now the thread 1 will be waiting for its turn again in the queue. Okay, there is the queue. In that queue, it will wait for its turn by accessing that thread scheduler, right? So once the threads are completed, some other threads are completed, then you assume that T1 is getting the turn to resume its process. Then it will call the resume method to continue its process. Again it will get into the runnable mode, then getting into the execution mode, that is CPU will execute, that is called a running mode. Another thing is here, for example, if it is in the sleep mode, then we will get notify method or notify all for all the threads to allocate the CPU who are waiting in the blocked mode. And also there is the possibility of lock available, okay, for respective methods. If lock available, it is providing the lock to the threads which are waiting for the lock by this method, then for that methods also locks will be given and keeping in the runnable state. If CPU is idle, then pass into the CPU to execute, then it will become into the running state. So like this it will perform its life cycle. Okay, then you assume that all the threads, okay, you assume that thread 1 is completed its task. Once it is completed, then it will exit from the run method. Once it is exiting from the run method, then it will be terminated, right? This is one criteria. Another criteria is when thread 1 is running, right, unexpectedly it is terminating by abnormally by the user. Okay, user wants to terminate it, or any other issues are happened, some exceptions are happened. So through that, if it want to interrupt that thread, okay, to halt this execution, then it will be applied by using the stop method. Stop method is forcefully terminate the running thread T1, so automatically it will be terminated. So this is the life cycle of thread here. And what are the different states we have seen in the previous slide? New state we have seen, whenever new thread is created by using the thread class, that is object variable is T1, then it will be available in the new state. So in this state, thread is not yet started to run. Then active state is there. You look at that, active state is having two different states. One is runnable state and running state, which is invoking a start method. Okay, the start method is executing. It is invoking the active state. It moves the thread from new state to active state whenever the start method is executed. Here the active state is having two states. One is runnable state and running state. Already we have seen in this figure. The runnable state is here shows that the newly created thread is ready to run, right? Then it will be moving from the new state to the runnable state. Then in runnable state, a thread may be running or may be ready to run at any given instant of time. That means the thread is created here. Once it is created, it will be in the new state. Then we are calling the start method by invoking start t1 dot start. Then it will get into the active state. If CPU is idle, it will be immediately kept in the running state. If CPU is not idle, then it will keep in the queue for ready to run. Okay, so this queue is maintaining the threads for ready to run. Then it is the duty of thread scheduler, as I said, to provide the time to each and every thread, right, to execute. The program is implementing the multi-threading acquires fixed slice of time for each and every individual thread. That means to execute the thread, we have to allot the time, that is called time slice. Once the time is over, the thread is voluntarily give up the CPU to another thread. For example, you assume that here T1 is currently running. Okay, then you assume that we are having one more thread T2, right? So T2 is in the runnable state. For T1, we assume that only 20 seconds allocated. If the 20 seconds are over, then automatically the T1 will be coming into the queue. Okay, coming into the queue, right? So now T2 will be getting the CPU. So T1 is now waiting for its turn. Okay, again, so T1 will be executing by voluntarily retiring that T1 by thread scheduler. So so that the other threads can also run further slice of time. So this T2 will you assume that 20 seconds, within the 20 seconds, if it is completed, then it will be terminated by the thread scheduler. That means completes its task. It is terminated after completion. If it is not executed within the 20 milliseconds, I mean 10 seconds, then again this will be kept in the queue, and T1 will get again second turn to resume its execution, right? It will continue the execution. So like that, the voluntarily threads will give up the CPU once it completes its allotted time slice. Whenever such scenario is occurring, those threads are willing to run, those will be kept in the queue based upon this approach. Here running state is available to allot the CPU to the thread which are available in the CPU. Then it moves from the runnable state to running state. Generally, the most common change in the state of a thread is from runnable to running and again back to the runnable. That means as I said in the previous scenario, T1 comma T2, right? If T1 is completes its time slice with the 20 milliseconds, then it will keep in the queue. Then the CPU will be allocated to the T2, right? So like that, the queue which is available in the running state, it will be keep in the runnable again after completion of its time slot. The block state is another state whenever a thread is inactive for span of time. That means if temporarily, if any thread is kept in the waiting state or inactive, then it will be available in the blocked state. Either thread is blocked or in the waiting state. Okay, if it is inactive for small amount of time, it will be kept in the blocked state or in the waiting state. Or if you are fixing some seconds or milliseconds, then that will use the timed waiting state, okay, by using different methods. Then here, what is the waiting state? Waiting state is here thread is switching to the waiting state while the thread is waiting for another thread to perform a task. That means that here the T1 is kept in the queue, that means waiting queue, because the thread 2 is running now. Once it is completed, then it will continue the process, right? Here the thread is moving back to the runnable state whenever we are introducing wait state or block state or timed waiting state. So these are introduced by using the object, that is t1.wait, or here t1.join or t1.park. So like that we can use different methods for making the thread into these different kind of states. Now we are looking that state transition of that particular thread. So here before that we should say what are the methods available. Suspend method is suspending the thread for a quite time, and resume method is used to continue the process of that suspended thread. Here the sleep method is used to make that running thread to sleep for a particular time, milliseconds, and join method is which is introducing to make the thread to wait for another thread to terminate its process. Here state transition says once T1 is created, automatically kept in the new states, then T1 dot start is calling the method, right? Once it is invoked, the T1 is kept in the runnable state. That means T1 is ready to run, okay, ready to run or ready to execute. Then if CPU is idle, okay, automatically run method will be invoked by this start method by using the thread scheduler. Then CPU is allocated for that T1, then which is in the running mode, right? So once it is completely completely executed, then it will call the end of execution and it is terminated, right? Otherwise, suppose you assume T1 is not completed successfully, before that we are introducing suspend method, then it will be blocked, kept in the blocked state, right? After some time it will resume the process, right, by keeping in the T1 again in the runnable state. Once CPU is idle, again run method will call that run method is already called, so again that process T1 will be allocated to the CPU to resume its process. Then it is, if it is completed, then end of execution and terminated. Otherwise we are introducing that here the thread, right, the wait state, okay, wait state. If it is wait state introducing for the T1 which is running here, then it will be kept in the blocked state. Then notify method will be issued after some time. If the CPU is idle, then again T1 will be kept in the runnable state. Now it is ready to run, then T1 is passing into the CPU, then automatically it will again come back to the running method. Once it is completed, then it will say end of execution, right? Otherwise, suppose T1 is running, right, in that running T1, if you are introducing the sleep mode for some time, then again it will be kept in the blocked mode. So after that, again it will get notify method to continue the process. After some time, again T1 kept in the runnable state. Then if CPU is idle, CPU will be allocated to the T1 to continue the process. Then if it is end of the execution, that will, it will be terminated, right? So sometimes once the new thread is created, abnormally there is the possibility of terminates its condition by introducing the stop method. So that is called here directly it is terminated, it is reaching to the dead state. Few times the newly created thread, it may be available in the blocked state, okay, due to this suspend method or wait method or sleep method. So during the thread available in blocked state itself, there is the possibility of terminating the thread running, I mean thread which is available in blocked states. At that time also it will be terminated or killed abnormally. So these are all the transition of each and every states, I mean when the thread is moving from one state to another state. That means this is showing the transition of thread between different states, right? So whatever we have seen, that is given here. Timed wait state is representing a runnable thread can either waiting for, I mean can enter the timed waiting state for specific interval of time, that is in the form of milliseconds. A thread in this state coming back to the runnable state when the time interval is expiring. As I told you, wait for some time, 20 milliseconds. After 20 milliseconds, then automatically the thread will come back into the runnable state. So here some example methods are given. Thread means t1 dot sleep per milliseconds, t1 dot wait some milliseconds, t1 dot join some milliseconds, t1 dot park nanoseconds, some nanoseconds it will be waited for a log. Okay, this is also park until some nanoseconds. And the termination state is the dead state or termination state. That means a thread completed its execution, means it will be come into the terminated state for its I mean for completion, that indicates the completion of that state. Otherwise sometimes abnormally it will be terminated due to unhandled exception or segmentation fault. So like this we can introduce the transition of thread from one state to another state by using this new state or running state or runnable state or blocked state or finally terminated state. Thanks for watching.